My name is Nigel Watson. I'm going to be discussing the disassembly of the 4280 gas control valve here in front of me, specifically with the removal and replacement of the cartridge assembly. As you'll see at the moment, I have removed the 18 or at least 17 of the hold down bolts for the actuator, and I'll begin by removing the last bolt. The lid should come up without any problems. From there on, we will look into the removal of the actuator assembly, and this is performed by removing the 4 bolts underneath these spacers, and we do this by using a 9/16 ratchet set and begin on all 4. Once we have removed the 4 bolts that hold down the spacers between the actuator and the control valve, we then need to remove the set screws within the coupling that is located in between the valve and actuator. There are 2 set screw locations, and each set screw hole has a quarter inch diameter set screw in them, and there is an outer set screw and an inner set screw. Both set screws have to be removed to remove the coupling from the valve. It is only necessary to remove the lower at this time. There. Having removed or backed out the set screws, it is then possible to remove the actuator assembly complete and separated from the valve. You will note that there is a keyway between the shaft of the valve and the coupling of the unit. Retain this for use next time on reassembly. Now we remove the lid of the valve, and again use a 9/16 socket. There are 2 bolts that hold this lid down, and the lid should come up fairly readily. Okay, separate the lid from the valve, and that will expose the cartridge within the valve. To remove the cartridge, we use the 4280 puller, but in fact any threaded insert with a 5/8 18 thread can engage on this thread of the rotor and subsequently remove the assembly from the valve. To the thread of the cartridge assembly and then remove the cartridge. The cartridge is loaded on 3 O-rings and should remove fairly smoothly. Cartridge can now be removed entirely from the unit and remove the puller from the assembly. There we have our cartridge assembly. Following the removal of the unit, ensure that the bore inside the valve is clean. Wipe it out, free from any excess particles, and also wipe the exterior of the cartridge that is to be replaced into the valve. Now take a grease. We use and recommend Dow Corning 3452 grease. It's a high temperature lubricant, and apply the grease around the O-rings. Don't need an excess of this grease. Essentially, you're looking just to lubricate the O-rings. Having lubricated the O-rings, use the pin to line up with one of the two holes in the casting. This is the lid holes. Essentially, line them up, and with some firm force, insert the cartridge assembly into the valve. Having performed that operation, wipe the excess particles or contamination from the surface of the lid. Apply a small amount of grease to the lid O-ring and replace the lid on the valve. You'll note that the hole in the lid cover should line up with the pin within the cartridge assembly. Now it remains to bolt down the lid using the two bolts, again 9/16 head socket, wrench to replace the units. And snug the bolts down firmly. Having bolted down the lid with the two bolts and secured it, it's now time to assemble the actuator and coupling onto the valve. This is performed by inserting the key, which is the 1/8 square key, into the keyway of the coupling and aligning it so that the keyway, you can do that by moving the coupling, so that the keyway will align with the rotor. This can be performed by approximating the keyway location with one of the lid bolts, and also similarly with the keyway of the coupling. Again, this actuator has 180 degrees of symmetry, so you can replace it in two locations. There is no problem to the performance of the actuator. Having done that, it's now time to lift the actuator assembly, and frequently can be performed easiest by two people, one person supporting the weight of the unit while the other one guides the unit into the keyway. until the spacers meet with the lid of the valve. Following this, Loctite thread locker 242 should be used in conjunction with the bolts, and apply a small drop of the fluid onto each of the 4 bolts.
Show it in front of the camera.
Prior to insertion into the spacers. The thread locker, Loctite 242, will ensure the bolts are fastened and secure. Having them inserted the bolts to their fullest extent by hand, tighten the bolts till they are firmly secure and seated. The next step in the operation is to re-secure the set screws in the base of the coupling. Remove, as you've already done completely, the set screws, and apply a drop of thread locker 242 to secure set screw. The set screws are removed using and reapplied using a 1/8 of an inch hex bar tool. Insert until fully honed and torque down. The backup set screw, there is a backup set screw for each of these set screw threads. Again, the smaller set screw should be replaced behind the longer one, and again using thread locker 242, and torque down until fully seated. Following the assembly of the actuator onto the valve, we're now in a position to set up the unit with respect to the closed position, the 0 position, and we've since rotated the valve through 180 degrees and put a flange plate on the upstream portion of the valve. The upstream is denoted by this flow, and this is the upstream, this is the downstream portion of the valve. At this point, we have our connections made to the inside of the actuator. These connections go to this control panel, this 8412 control panel. The closed stop must now be unlocked or unscrewed so that the stop within the actuator is free to move. And then we will use the actuator panel to move the valve incrementally through its closed to the open position. I'm going to use compressed air for this demonstration of finding the 0 point. And I will plug it on with a quick release fitting to the upstream valve portion. And prior to opening the valve, I'm going to set up the unit so that it will go to the fully closed position in the auto setup mode. But before I turn the power on, inside of the panel there is a micro switch on the edge of the printed circuit board. It is in the run mode. It should be moved to the lower position to the config mode. And at this point we can then turn the power of the panel on. Okay, with the power on, we now show a flashing light, green light, which indicates the power, and in the display it says set up main and manual position. We don't want that position, so we will scroll through to the next position by pressing the up arrow where it mentions auto setup. At this point we do want that, and when I press the select button, the actuator will start to move anti-clockwise until it hits a solid stop. And it will then indicate about a -2 degree position, a -2 degree closed position. Now this software shows -2 degrees, but indeed the valve has not been set up for that condition at this moment. Now I will turn on the air supply by means of this block valve, which should allow air to bleed through the valve. And you can feel it, you can hear it, the air bleeding through. We're now going to use the up arrow to gradually increase the flow of gas. This up arrow will incrementally rotate the valve rotor in a clockwise direction to open the valve. So I'm going to start pressing the up arrow, and you will gradually notice an increase of airflow through the valve. When the airflow starts to increase significantly, that will indicate the 0 position of the valve. We're now reading 0.32, no significant change. Now reading 2.26. Again, it's starting to increase, but not significantly yet. As you can hear, the flow is increasing. Now we have gone beyond the 0 position now, so I will back it off using the lower arrow. 4.85, 4.41, 4.15. It's around 4 degrees on this position is when it starts to take off. So at that point, in order to set the stop, I need to take the unit back 2 degrees, which will be from 3.97, I subtract 2 degrees to 1.97 degrees, and that's where I will set the stop. So I move the lower arrow to 1.97. .02, which is close enough for our calibration. And I will now set the stop. In order to set the stop, there is a 9/16 bolt, head bolt, inside the actuator, and I'll use a 9/16 socket wrench to screw it down. I will also need a screwdriver in order to secure the stop against the butterfly gear or drive gear of the actuator. Tell me when you're ready.
Go ahead.
Okay, this close-up view shows the stop in the lower end and the bolt that is required to tighten down the stop in this position. While you're tightening down, it's important that this stop be up against the drive gear, this butterfly gear here, and again torque it down until it's tight.
Put the wrench on it.
I use this 9/16 socket and firmly tighten. Following setting of the stop in the upper portion of the actuator, we need to go back and redo the zero stop consistent with the -2° stop within the actuator. In order to do that, we need to press the right-hand button, the escape button, and again it will show manual position, and I don't want that. I'm going to scroll through to the auto setup, and then I'm going to press select to enter that, and again that will set the actuator off to return to its zero position, or rather the -2 position, consistent with the software. The control panel now displays -1.84 degrees, which is somewhat consistent with the stop now for -2 for the flow. Just to recheck that we have our position of zero being the point at which the flow starts to take off, essentially the valve opening, I will increase it incrementally to zero to check. I've got 0.06, 0.24, 0.59, 0.9, 1.29. Flow is increasing significantly, and I'm satisfied if I take this back to zero that I have indeed defined the zero. We have now configured the -2 stop, and we also know where the zero position, the closed position of the valve is. We also now have to calibrate the control panel and the actuator against the zero position, the closed position, and the 100% open position. For this purpose, we will actually shut off the airline by means of the lock valve, and we will use a known milliamp source. This is a 4 to 20 amp milliamp source, and I've already pre-hooked this into the panel in the positions in the connector. This will already be configured into your panel, but essentially what we need to do now is configure the panel so that when the source reads 4 milliamps, the valve will be in the fully closed position, and when we provide an input of 20 milliamps, the valve will be in the 100% condition. As you can see, we're in the -2 degree position at the moment. That's basically at the stop position. I will now advance the actuator to read approximately 0. This is reading 0.06. That is within the bounds of calibration. Aim for a plus or minus of about 0.1, and that should have plenty of accuracy for the purpose of calibration. At this point, I will now provide a 4 milliamp source, and this is against the 0 position, and I will press select. The next line item says for 63 degrees, which is the 100% position, and I will provide the 20 milliamp signal, and again press select for the full open position. The display now reads valve configured, and the calibration is complete. The signal generator, the 4 to 20 milliamp signal generator, will now be moved back to the 4 amp position, 4 milliamp position, and the panel cover opened, and the final remaining item on the list of calibration is to return the micro switch to the upper run position, and the unit is now calibrated and set.